Hey, welcome to yesterday's recap. What did we write in our app yesterday? So, in the app currently we have a variable declaration here which points to a string, and we also have another variable which points to an empty list. Then we write a while loop which will run over and over again. So in each iteration it asks the user for input. The user enters input. The input is stored in the to-do variable. Then we print out the capitalized version of the user input. So the user entered text, we capitalize the first letter of that text. We also append that text to the to-dos list. So in each iteration, what we do is we append values to the to-do list. So the to-dos list is populated with values over and over again. So that's the code of yesterday. Let's move on to the next video and start the day. Hey, in this video you will learn how to have your program take decisions. In other words, you can make your program more intelligent so that it responds to different ways depending on the user input. So exactly what we'll be doing is we will allow the user to decide what they want to do. So whether they want to add a new to-do or to see the existing list of to-dos. Because currently the way the program works is that the user can enter a to-do and they see the list of to-dos, they enter another to-do, they see the list again. So how about not showing the list by default, but only showing that if the user wants to see it? We can implement that using the match case statement. Now, match case is only available in Python 3.10 or newer versions of Python. Therefore, for this to work, you need to use at least Python 3.10. Right, so how do we implement this decision making? Well, first we want to ask the user if they want to add a new to-do or if they want to see the to-dos. So what I'm thinking is of changing the message here to type add or show. So that's just a string. The string goes in here. I would simplify this actually and just put the string directly here so we don't have so many layers. Both versions are fine, but I do think this is a bit more readable. So by looking at this, you understand that you are asking the user for input, since this is an input function, and you see what message you are showing to the user. Now, the user is expected to enter add or show, and add or show will be stored in this variable. So to do will be equal to either add or show, but I want to change the name of this variable now to make it more meaningful. User action would make more sense. And then we say match user action, a colon, and press enter, and you'll see that PyCharm automatically indents the next line. So this match is a block. The match case statement is a block, just like while true. So match user action case add to do is equal to input enter a to do. Let me complete this and explain it to you what I'm doing. Case show print to-dos. And this will go down here. And this will be deleted. And that's a complete code for this video. Now let me explain to you what this means. So we start here, match user action. This variable, as I said, is this one here. It will be either add or show. So we're trying to check here the value of that variable. We're trying to match that variable. So if the value of that variable is add, so if the case is add, then what we do is we ask the user for a to-do. So they will be prompted again to enter some input. They will enter their to-do, such as clean the bag, and that to-do will be appended to the list, to that list, and that's it. If the user action was show, so if the case is show, then we print out to-dos. So let me execute this. And so we get this user prompt type add or show. If I press show and press enter, we're going to get an empty list because currently there are no to-dos. So if I press add, then I get this prompt to enter a new to-do, clean the bag, press enter. Again we get type add or show. Why do we get again type add or show? Well, because when we were asked to enter a to-do, we were at this point. And we entered a to-do, this was executed. And so the loop will be repeated again. So it will go and ask for type add or show again. So user enters add, for example. Add is stored in the user action variable. The match case again checks if it's add, it does those things. If it's show, it does that thing, and then goes back again to the first line of the while true loop, which is this line here. And so the loop iterates over and over again. Now, how about adding one more option here? Type add, show, or exit. So the user can also enter exit. In that case, we want to add another case here, case exit. We want to exit the program at this point. The way we do that is using the break statement. So you just write break there, and that will break the while loop. And so since there are no more lines of code down here, the program will end. Or you can add here print by, and let's see how this works. So rerun the script. Type add, show, or exit add. Prepare the helicopter. Type add, show, or exit, exits. We get by, and the program finishes its execution. And that is the complete code for this video. Thank you, I'll see you later. In this video you will learn one of the most important elements of the Python programming language, and that is the for loop. So why do we need a for loop in this program? Well, when we execute the program and we add, for example, a to-do, clean, and then we add another one, add, throw, and then if we press show, what we get is a list. So this is a list object, and it's not very user-friendly. The user doesn't want to see brackets, they want to see just text, and they also don't want to see these quotes around the to-do items. So how can we output each to-do in one line? So one to-do item per line, without brackets, without commas, without quotes. Well, to do that, we need to print out each of the to-dos using a print function. So basically what we want to do is we want to go to the show case, and instead of printing out the list, we delete that and we say for item in to-dos, print item. So notice the level of indentation here. So the while loop is at the very first level of indentation, and then match is one level beneath that, and then we have case at another level, and then we have the for loop. So the for loop is indented 3 times, 1 here, 2 and 3. And so print is part of that loop. The function now, this print function, will be executed as many times as there are items in the to-dos list. So let me run this again. Add, clean, add again, throw, and now I want to show. So show, press enter, and there we go. That's the output. Clean and throw. So that's about the for loop. We will cover the for loop later on in the bonus example. But what I wanted to show also is how to make a small improvement of our program. Because what happens is that if you press add, so the program is asking us to type in add, show or exit, and if you press add and then maybe you make a space, a white space character, and then you press enter, the program will not recognize that because it is not add, it is adds plus white space. So for Python, that is a different string. So add and add, if you use this comparison operator, you'll get false. So those are not the same strings. While if you say add is equal to add, yes, that is true. So that is a comparison operator. It is not an assignment operator. It compares two values to check if they are the same. So how can we make our program more intelligent in this point? Well, we can simply apply here a string method which removes that trailing space from the string. So for that we can use the strip method. The strip method works like this. Let's say the user action, which is a variable, will be equal to add with a space, and then if you do user action dot strip and you press enter, you get add without the space. But note that if you call user action again, you will again get add with the space. So what happened here is that this strip method simply returns a new string, but it does not change the string in the user action variable. So if you want to save the changes to user action, you have to say user action equal to user action dot strip. Execute that, and now user action is going to be add without the trailing space. So this was just the Python console. To have the changes in your code, of course, you need to input that expression somewhere in here. So I think we should put it in here. User action is equal to user action dot strip. So we get add, show, or exit, and if add has a trailing space, we strip it. If show has a trailing space, we strip it out, and so on for exit as well. So at this point we get a clean command without spaces, and then we match that to add, show, or exit. So that was a nice addition to our program, and that's the for loop, which we will cover again later. So that's about now. See you later. Hey, welcome to today's code experiment. In this video, we're going to run 2 experiments on the match case block and 1 experiment on the for loop. Let's first start with the first experiment on the match case block. So when we run this program, as a user, we are expected to enter either add, show, or exit. But what happens if we enter something else, like a random piece of text? If you press enter, the program will ask you again to type in add, show, or exit. So my question to you here is, what happened after we entered this random string? Which of these code blocks was executed? The one under add, the one under show, or the one under exit? The answer is none of them was executed. What happened is that all these lines were ignored because the case was not matched, and therefore the loop went again back to the first line. So the while loop was executed again. And that's why we get this text printed out. So that is the result of this line being executed. Now, what if we wanted to show something, some other text, when the user enters some text which doesn't match any of these cases? Well, in that case, you should add another case here, and instead of matching the random string, you want to place a variable, such as x or whatever. It just has to be a variable, and you don't need to define it anywhere in the code. So this variable will be defined on the fly. So you say case x or whatever variable, and under this, perhaps you want to print a message such as, hey, you entered an unknown command. So if I try the script now, run, and I entered a random string again, press enter, this time we get this printed out. So as you can see, this time this code was executed because the case was matched with that anonymous variable. As a convention though, instead of using whatever variable name here, it's good to use just an underscore. So this name is like a convention to have among programmers so that you know what you mean when you have this code. So it's good to use that underscore, even though you don't have to. And so that was the first experiment. So this is what you can do if you want to execute some lines when none of the cases is matched. We're not going to implement this in the program, so I'm going to delete that. It was just to show you that that is also possible. And the second experiment is, let's go to case show and make a space and then type in a vertical bar symbol. On your keyboard, you can type this in using Alt7 or Shift \, perhaps. It depends on your keyboard. Or maybe you can find this on Google and copy and paste it in your IDE. And after this, I will write another string, display. If I run this code and I add a to-do, so I press on add, press on clean, press enter, and then instead of show, I can also write display here. And if I press enter, I'll get a list of to-do items. So this is a bitwise OR operator. So this will match either show or display. So if one of these strings is matched, then this is evaluated to true, so these lines will be executed. Alright, that was the second experiment. Let me delete that as well. If you want, you can keep it, but I don't want to have lots of code here. I don't want to add any possible feature to this program because that will make my code complex, and that means it can be harder for you to see what I'm typing in and what I'm explaining. So it's better to keep the program simple but functional so that you understand the new concepts. The third experiment, I want to focus on the for loop this time, and I just want to make sure that you know that you can add more lines under the for loop line. So under the first line, for example, you can say item is equal to item dot title. So we get the to-do items, each item, each string in the to-dos list, and we convert the characters, the first characters of those words into title case, and then we print out the results. So we reassign this variable. Let's see what this will bring us. So run add, clean the bag, add, throw the trash, press enter, show. Now show will display the to-do items with the first letter of each word capitalized. So C is capitalized, T as well, and so on. And that is made possible by this title method. So my point with this experiment is that under this line you can have as many lines as you want, but be aware that they should be all indented in the same indentation level. So that means 4 spaces for each of these lines under the for line. And that was the last experiment, so I hope this gives you some more understanding of the match case block and the for loop. I'm glad to still have you in the course, so let's keep going. See you. Hey, in this bonus example, I want to focus on the for loop. I want to make sure you understand what the for loop does, because a for loop is something that you'll use over and over again when you create applications. You saw the for loop here inside this match case block, but the for loop can also be outside, of course. So let's suppose we have a list of meals. Let's say we have pasta, pizza, and salad. So if you want to print out these in the command line, you do for meal in meals, print meal. So if you run this, you get pasta, pizza, and salad. And of course, you can add methods such as capitalize to capitalize the first letter of each word. So what's going on here is that this meal is a new variable. This variable is created on the fly. So in each iteration on the backstage, what's happening is something like meal is equal to pasta. That's what happens in the first iteration. And so pasta that's capitalized is printed out by the print function. Then in the next iteration, the variable is declared again implicitly. We don't see it, but the variable again is pizza this time. Pizza is capitalized and is printed out. And that's how it works. And if you say print by at the end, by will be printed out when the iteration finishes. So we get all the items of the list printed out first, and then comes by. So the for loop behaves like the while loop. The difference is that while loops run as long as a condition is true, and for loops run as long as there are items in the lists which is being iterated. And you can also iterate over strings, not only over lists. So here we are iterating over this list. Now, if you change meals to a string, let's say like that, and run, this is what you're gonna get. M-E-A-L-C, and each letter is capitalized, because now meals is not that variable anymore. So that is not being used, we can delete it. So run again, you get meals, M-E-A-L-S. So lists and strings have this similarity. They are treated as sequences of objects. So the list in our case had 3 objects, which was pasta, pizza, and salad. Our string in this case has 1, 2, 3, 4, 5 objects, which are strings. So each of them is a character, and you can iterate over strings. Of course, in this case, you would want to change this variable to a more meaningful name, maybe char, which means character, or whatever you like. So now it makes more sense. I hope this gave you some more clarity on the for loop. Thank you for following. Let's suppose you are walking in the Amazon forest. In the forest, you meet a tribe, and the tribe has a cook. You want to tell the cook that you are hungry, so you need to eat. The problem is you don't know the language. So what you get is an interpreter. So that is the interpreter. You speak English to the interpreter, and the interpreter speaks Amazonish to the cook. And the cook serves you the meal. Python works the same. This is you again, and you want to communicate with the processor of your computer. For example, you want to know the sum of 3 and 4. The problem again is that the processor speaks a very difficult language called machine language. And this language is very hard for humans to speak or to write. So what we get is an interpreter called CPython. So what is CPython? CPython is the software we installed in the previous videos. So when you download Python from python.org and you install it, what you're installing is actually CPython. It's an interpreter. This interpreter gets Python language from you, and it translates that language to machine language, and it speaks that machine language to the processor. In return, the processor uses the computer display, so your laptop screen, to display the results. For example, 7, and you see that 7. So as you can see, Python is just like English. It's just a language. The software you install and you use to execute Python is just a software, and it's written in C language. It happens to be written in C language. That's why it's called CPython, even though most people refer to it as just Python. When you say, did you install Python? Well, you're speaking of installing CPython. The Python language itself is just knowledge. It's stored in documentation. If you go to python.org and then go to the documentation menu, then you should see the documentation of Python. So the documentation of Python is the equivalent of a dictionary, an English dictionary such as Oxford Dictionary, where the English language is documented. There is one difference though. In the case where we spoke to the cook, we used spoken language. In the case to communicate with the interpreter in here, we use text files. So we write the language in a text file, and the interpreter reads that text file. In this case here, the interpreter, he listens to the sound that we speak. Of course, we give the extension .py to these text files, but they are still text files. The extension is different. And that's the idea. That's what Python is. So Python is the language. And thanks for following this example, this comparison, and I'll talk to you in the next video.